Okay, so based on that lecture, kind of dry, right? And so I'm trying to think of some ways to do this with my students. And of course, I'm talking about in chemistry. So they have a good background already about how to name substances. But I have before given them formulas and names. So like back to the previous slide, like we did, just little cards, and have them try to come up with what they think the rule is to get to the name from the formula. Have them come up with how the Roman numeral came to be there. You could give them the periodic table with the charges already there, and kind of see what they can come up with. So just some ways to make it more inquiry driven instead of just telling them what the rules are. But definitely, as you're going through your lecture, if you teach this to your students, you'd want to interject some times when they could practice, and you can kind of walk around and see how they're doing. So it's just some different ideas for you there. So now let's kind of segue. We were talking about how to get from the formula to the name, and so now we have to know how to go back the other way, how to go from the name to the formula. And it's actually a pretty simple method here, but we want to understand why the method works. So just talk about the method first. What you're going to do for ionic substances is you're going to write the symbol and the charge, and then cross the charge down, just the number, not the positive negative sign, okay, to become the subscript. And the subscript, is these little numbers here at the bottom. If you have a polyatomic ion, you need to put in parentheses if it has a subscript. Our example here is magnesium nitride. So magnesium is Mg. We look up on our periodic table, it's a +2 charge. Nitride is nitrogen. Look it up on the periodic table, it has a -3 charge. So we put the 3 down here to go with the Mg. We put the 2 down here to go with the nitrogen, okay? That method works every single time. And the reason why it works is this. Remember we talked about before, to figure out those charges on the transition metals, everything has to equal out to be 0. So if you look at your formula here, if we have 3 magnesiums, which are each +2, that's going to give us a +6 charge, right? 2 times 3, +6. And if we have 2 nitrogens, each at -3, that's going to give us a -6 charge. -3 times 2. When you add these two together, what do you get? You get 0. And so that's why the cross-down method works every time. So it's actually pretty simple if you know what the charges are. And that's why it works. So why don't you try it? I'm giving you a couple of examples here. For polyatomic ions, phosphate, again, that's PO4 with the 3-, excuse me. Carbonate, CO3, 2-. Cyanide is CN, so that's a carbon and a nitrogen with a -1 charge. So there's your polyatomic ions if you don't have those memorized or don't know those. And now you should be able to try these. So go ahead and pause your video again and try it out, see if you can get your formulas. Okay, now that you've had a chance to work these out on your own, let's go through them. Calcium chloride, so calcium is +2, chloride is -1. Cross it down, and you would get CaCl2. Lots of different things you can do here with students. You can have them kind of draw pictures. You can get those manipulatives that you'll sometimes find, like I've seen before. So your calcium manipulative would look like something like this. Try to draw it. You've probably seen it. Like that. So it'd have 2 little juts in there. And then your chlorine would look more like this. So it'd have 1 jut coming out. Okay. So it's +2, so 2 juts, and then chlorine's got 1 jut. So your students could kind of fit that in, and then they'd say, oh, it's not complete, I haven't finished my puzzle. So they'd have to conclude then that they'd need another chlorine piece. So you see that a lot. And that's where they would then come up with the formula, 1 calcium, and then 2 Cls to balance out and equal 0. So you can definitely find these online. You can make them yourself. You could draw pictures. Another thing I like to do, so if calcium is +2, I know it has 2 positives. So like that, Chlorine is -1. So I'm not all equaled out here, so I know that I need another Cl. And so from this drawing, we could get to our formula of CaCl2. So there's lots of different things you could do for students. They can figure out what these formulas are. Let's just finish out here. So we've got sodium, which is +1, phosphate, which is -3. Cross it down, you get Na3PO4. In other words, it takes 3 positive sodiums to balance with 1 -3 phosphate, like that. Ammonium carbonate, oops, I forgot to tell you, ammonium is also a polyatomic. It's NH4+. And so NH4+, CO3 2-. This is the first time we've had to use parentheses. And we'll see if this makes sense to you. We would not want to write this as this, you know, cross down the 2. Because we write it like this, what the formula means is 1 nitrogen, 42 hydrogens, 1 carbon, and 3 oxygens. That's definitely not what we mean. We mean 2 ammoniums, right? So I need 2 positive ammoniums to balance with 1 -2 carbonate. So this is my formula. Copper 2 cyanide, so don't forget, what's this 2 mean? This 2 gives you the charge of the copper. So it would be Cu +2, Cn minus, cross it down. And this one, a lot of times my high school students will miss because they'll do that right there. But that's wrong. What this formula tells me is 1 copper, 1 carbon, 2 nitrogens, which is not correct. We want to show this as 1 copper and 2 cyanides. So all polyatomic ions must be in parentheses if they have a subscript because it's a unit, it sticks together. Chromium 3 oxide, so it'd be Cr +3, and then oxygen is -2. Cross it down, and we get Cr2O3. And so those are our formulas. And everything balances out and adds up to be 0.